All right, ladies and gentlemen, we are now going to go into Chapter 2. This is Chapter 2, Frequency Distributions and Graphs. So, oops, here we go. All right, so as an overview, as an outline, Chapter 2 is talking about how to organize the data in a way that is meaningful, that can help you understand the data, can help you explain the data, perhaps enable you to convince somebody of taking some particular course of action. That's section 2-1. 2-2 is talking about ways of visualizing the data so that it makes a little bit more sense. And similarly, 2-3 is basically the same as 2-2, just different examples. And I should mention this is chapter 2-1. This is recording number 1. And we're going to be talking about this idea of frequency distributions and graphs. I want to mention also that the word frequency distribution, or this terminology, frequency distribution, what that refers to is how often something happens. And if some of you have taken any physics, you might be a little bit confused by this word frequency, because normally when we talk about a frequency in a physics context and in many math contexts, we're talking about a periodic function. How often does it happen over a period of time? So the meaning here in statistics is slightly different. When we talk about frequency distributions, essentially all we mean is how often does something happen. Okay, so as always, we have a objective, which I do recommend that you take a look at. The book does have a little explanation about how statistics can be used in day-to-day life. I think that's worth your time, but it's not worth my time, or it's not worth your time to listen to me read it. It's worth your time to read it, to be more precise. We'll open this up a little tiny bit here. Okay, so I think the first part here is pretty self-explanatory. When the researcher is gathering data for some particular variable, okay, as an example, wants to study the number of people who are bitten by snakes in a certain area. Well, you have to gather the information from various places, right? Well, pretty soon you have all this information. It's just a mess. You can't really draw any conclusions from it. It's very difficult for you to really make any sense out of it. So that would be, as we discussed before, that would be descriptive. Excuse me, one second. Okay, so it would be descriptive statistics to describe the situation. Then if you want to draw conclusions, of course, then it's the inferential statistics. All right, so in order to do this, you need to organize the data in some meaningful way. All right. So the most convenient way of doing that is to construct what we typically refer to as a frequency distribution. And then after you organize the data, you have to be able to present it. So there's no magic here. It's just a matter of presenting the information where people can understand it. Okay. So here we are in section 2-1, organizing the data. And this is an example of what I've talked about before, I think, and that is sometimes these examples you look at and you roll your eyes and you're like, oh my gosh, this is so boring. Who cares about any of this? But these are just examples or analogies or metaphors for things that you will be interested in and that will be important to you. Unfortunately, we have to use these simple examples just to explain things without going into all of the details of whatever it is that you happen to be interested in. So take that, take that to heart. These are just examples. There'll be a lot more relevant examples in the exercises that you might find a little more interesting. All right, so we're talking about the ages of the 50 wealthiest people. Okay, so you have 50, you have 1, 2, 3, 4, 5 columns, 10 elements in each column. Okay, so you write it down. You write down what the ages are. Well, that doesn't really help you very much, does it? I mean, you just look at that and you can't really get much real information that is of any value to you. So that's what we would call the raw data. In order to organize that data, we're going to organize it into a frequency distribution. And a frequency distribution is the organization of raw data, and it's going to be in a table form. Now we call this a table, right? It just is a table of information. And we're going to use classes and frequency. So classes is over here, and then this is the frequency over here. It's how often. So the idea is that you have a class limit, like you have the class limit is the ages, right? So the class limit from age 37 to 35, age 36 to 44, age 45 to 53. You see how quickly this gets boring, okay? Then you have a little tally here. You tally it up, and then over here you have the frequency, okay? So now you can make perhaps some general observations. You look at this and you say, well, gosh, it looks to me like pretty much the majority is 45 or older. There's only 4 people over here in that younger age group. So that would be an inference that you could, not an inference perhaps, but that would be some sort of an observation that you could make, okay? All right, so now we call these the class limits. Class limits is, the classes or the categories or the sets that we're using, okay? So now the most common ways we do this is a categorical frequency distribution and the grouped frequency distribution. And we're going to talk about this here in just one second here, all right? Okay, so now, do you remember back when we talked about this before? This was in section 1-2, and in my edition of the book, the 10th edition, it was on a page 1-8, 1-9. Now the page number up at the top of the page is 8 and 9. So anyway, we talked about what we called data that was nominal, ordinal, and so forth, okay? That was for data that can be placed in specific categories. So now you're saying, why did we talk about that back in section 1-2? We talked about it because now we're gonna use that. Okay, so data that can be placed in categories, that's the nominal data or ordinal level. Okay, so as an example, political affiliation, religious affiliation, your major field of study, that sort of thing. Here's an example, talk about blood types. Okay, so we've got these 25 guys and gals that join the Army. They're given a blood test, and we find out what kind of blood type do they have. And we want to construct a frequency distribution because, clearly if you just look at this, it doesn't really help you. You can't really understand it very much. Now that's just for 25 data points. You can imagine, I'm sure, if you had 25,000 data points, it would be ridiculous. You couldn't possibly get anything of value out of that. But if we put it into a frequency distribution, if we put it in a table that kind of organizes the information, it will help us. Okay, so let's take a look. We're gonna talk about the classes. What kind of a class are we going to have? We're going to have the different categories of the blood types. Okay, so you have now this is very confusing, I found anyway. Up here you have A, B, C, D. What the heck is that? What that is that just left over from the fact that when you're using an Excel program, program for making spreadsheets, the Excel program puts those letters up there. So this A, B, C, D has nothing to do with the frequency distribution. And I wish the author would have made that clear, or I wish the author wouldn't have used Excel. It kind of doesn't make any sense, right? All right, so the classes, the categories is class A, class B, class O, and class AB. Those are the different types of blood types. The tally, that's where you just put a little mark as you go along and you're counting these things. And then the frequency is how often you get class A, how often you get class B, and so forth. Then over here you can have percent, okay? So if you just plug all this stuff in there, it makes the data a little more interesting or a little more useful. Okay, the tally is pretty simple. That's just you maybe did this when you were kids or something, you just put a little mark there, right? Okay, so now frequency, that's how many times you have. So like you have 5 class A, 7 class B, and so forth. And then the percent, hopefully you remember how to do percent. Percent is just is a frequency over the total number multiplied by 100. So like does that make sense to you? I hope it does. For example, like right here, 5 out of the 25. So there's the frequency of 5, that's your F, frequency is F. the total number, n, is 25. So 5 over 25, that's that's 1/5, right? 5 over 25 is 1/5. 1/5, it can be written in decimal form as 0.20. We don't want to write it as 0.20, we want to write it as a percent. So to get it converted to a percent, we multiply by 100, and that gives us 20%. It's just percentages is just a convenient way of writing fractions. Okay, so we're going to go ahead and write it this way, and boom, there it is. That's your frequency distribution. So when you look at this, it helps you a little bit, perhaps. I mean, this isn't the most interesting example in the world, but you look at this and you say, gee, 36% of the people have type O. So for your planning purposes, if you're trying to plan for surgery or something, and you want to know what kind of blood sugar or what kind of blood type should I have on hand, this might be of some assistance. Okay. All right. So now this is called grouped frequency distributions. Okay. So this is categorical. Okay. It says right here, categorical is one of the common ways. Grouped frequency distribution is the other common way. And the idea here is that sometimes the range of the data can be very large, okay? Now we're talking about the other kinds of data. We're talking about numerical type data now. Okay, so we can have a very large range of data, and what we typically will do is we'll group it into classes that are more than 1 unit in width, and we call that a grouped frequency distribution. It's just a convenient way. So like here we have class limits between 58 and 64, between 65 and 71. It's just convenient for us to have these limits, these class limits, or these sets, because otherwise we'd have this left-hand side would be so long or so large, it just would be awkward. Okay, so it's very convenient sometimes to group it into classes. Okay, and we're going to call that a grouped frequency distribution for obvious reasons, because it's in a group. Okay. Okay, so example 2 gives us. It's going to be coming up here in just a second. This is example 2-2, right here, recording the high temperatures. Okay, so we have these temperatures that we're going to put them into categories, or we're going to put them into groups for convenience. So we'll see how to do that here in just a bit. But here he has kind of an explanation of how he recommends that you do it. Okay, now, there's no hard and fast way of doing this. You do one, you've done them all. Do at least 1 or 2 of these just to get the hang of it. Okay, this is not the most interesting topic in this class. Okay, so there's a procedure for doing it. Okay, all right, we call these the class limits here. This is the class limits. The class limit is from 58 to 64, from 65 to 71, and so forth. Now that's a little bit different from the class boundaries. In the class boundaries, just like we had boundaries before, we go up and down just a tiny bit. So we go a little bit down from 58. We go down to 57.5. For 64, we go a little bit up. We go up to 64.5. It's typically one more. It's one more. How does he put it here? Give me 1 second. Okay, here it is. It's talking about the difference between a class boundary and the class limits. The rule of thumb is that class limits have the same decimal place value as the data. So here's the class limits. So this data is going to be okay. I'm sorry. Yeah, let's look at this table here. This is blood glucose levels. Now, blood glucose, that's just your blood sugar, all right? So I'm almost out of time, so I'm going to end this video, and then we'll discuss this in my next video.